Hi, this is Prasanna from Vivek Navia. In this video, we are going to see about how to simulate buck converter in closed loop with the help of Matlab and Simulink. Straight away, we'll move on to the Matlab. So in this simulation, I'm going to use a PID controller in a closed loop. First, I will develop the buck converter. If you want to know about how to develop the buck converter simulation in detail, you can refer my old videos. Okay. Anyway, I will simulate. I will start from the scrap. So if you want to develop the buck converter, I need some parameters. I need some elements. I'm taking series RLC branch as three number. One is for my inductor, and one is for my capacitor, and one is for my resistive load. Values and all I will put it later. First I will complete the simulation. I need a IGBT, I need a switch. So if you look at this, in this switch, it's having the collector, emitter, gate terminal is there, and one more port, M port is available. Actually I don't want this M port. I'm disabling this M port. Now this switch is having three terminals. Okay, collector, emitter and gate. Similarly, I need a diode. So in this diode also it's having a anode cathode terminal is there, one more M port is there. I don't want this M port. If you want to measure diode current, diode voltage, you can use this M port. It's nothing but a measurement port. Otherwise, make this as a disabled one. Now this diode is having two terminals, anode and cathode. Fine. First, I will simulate the buck converter in closed loop with constant input. Okay. After that, I will simulate the same thing with variable input. So here I am going to take some DC voltage source. So it is a buck converter. So this what buck converter will do? Irrespective of input voltage, it will produce lower output voltage. Okay. I want the inductor to be in my output side, whereas switch will be in my input side. Accordingly, I'll develop the buck converter. And this is nothing but my filter or capacitor. Now the simple buck converter is developed. If you want to measure the input voltage, you can use a voltage measurement. Similarly, I want to measure the output. Okay, fine. I need a scope to see the output. So I want input terminal as 2, number of ports is 2, so that I can easily compare my input voltage with the output voltage. Okay, since it is a closed loop, I have to fix my set point or reference. Okay, so I I want to make my output voltage that should reach my set point or reference voltage. So here I'm fixing the reference voltage with the help of some constant block. I can say that this is my set point, or you can say it is reference or target, whatever it is, whatever the name you can use it. So let it be, this is my set point. I'm fixing my set point as 15 volts. 15 voltage is my set point. So now I want to compare my set point with the measured value with the help of a comparator signal. I'm going to use a sum. So this will act as my comparator. I'm just changing the position for my simple connection. I can say that this is nothing but it's a error detector or comparator, whatever you can say, whatever the term you can use. Okay, now the set point is compared with the measured value. I'm flipping this block. So now the output of comparator is nothing but it's a error signal. So that error signal is normally given to the PID controller, and that output of PID controller is nothing but it's a control signal that will be compared with the carrier signal. Normally the carrier signal will be a sawtooth waveform. The output of that comparator will be given as a pulse signal to the gate. So that is the procedure. Let us see how to do that. Here I am going to use a PID controller. Flipping it. That error signal is given to the PID controller. You cannot straight away connect this PID controller with gate. It's not a proper way of doing the closed loop. So I need a sawtooth generator as a carrier signal. We need a repeating sequence. Okay. So this is nothing but the repeating sequence. I'm comparing this repeating sequence with the control signal with the help of relational operator. So when the repeating sequence is less than or equal to PID, at the time I'm instructing the circuit to generate the gate pulse, which will be given to the diode, sorry, switch. So now the simple circuit is over. I will put up the values now. Okay, fine. So I need a power guide. So now I will give the values accordingly. So in this power guide, I'm going to prefer discrete power guide. Okay, discrete power guide with the value of 5 e power minus 7. So this is my sample time, and go to modeling Go to model settings. So in this solver selection type, let it be the variable step solver. I'm going to change the solver method and prefer ODE23T. And then I'm changing the relative tolerance, that is nothing but 1 e power minus 5. And then I'm changing my algorithm is adaptive method. Apply it. Okay, so this will give me the better output. Okay, so you have to know how to work with the configuration parameters. So these are all the parameters I choose in the configuration. Now I'll fix the input voltage. Say my set point is 15 voltage, so definitely input will be higher than the output. Say it is 30 voltage. Okay, since it is a buck converter, the output of buck converter V naught will be always lesser than the input voltage. Okay, so here the input voltage is 30 volts, but my set point is 15 voltage. Let us see how it will work. So before that, I'll put up the values. Inductor value, I'll choose 75 e power minus 6 Henry, that is nothing but 75 microhenry is my inductor value. And similarly, capacitor, I'm going to choose 250 e power minus 6, 250 microfarad. And the load value, the resistor value is 50 ohms. Okay, fine. My set point is 15 voltage. I'm going to fix the repeating sequence parameters. Say this one is 0 to 0.00004. Actually, this indirectly represents the frequency of my carrier signal. If you want to calculate the frequency of carrier signal, actually this parameter, this 0.00004 represents its a time period. If you want to calculate the frequency of the carrier signal, f is nothing but 1 divided by t. So this is the common formula which will help you to calculate the frequency of carrier signal. And then the output values I need is 0 to 1. Okay, this is nothing but my PID controller. I'll fix the PID values like this. So in this PID controller, I'm going to choose this discrete PID, and then in proportional controller I'm going to fix 0.45 is my KP value. Integral value is 43.5. Let it be derivative value is 0. Okay, so proportional gain is 0.45 and integral gain is 43.5. And go to output saturation, fix the upper limit and lower limit. Say lower limit is 0.1 and upper limit is 0.9. Apply it. Okay, now everything is fine. Before that, I will go to scope and I will change the style. I'm making this as white. Axis color is also white. My pen is black. And first channel, I'm fixing this is my black. Actually, first channel is my input, whereas channel 2 is actually the output. I'm applying it. Okay. If you want, you can add the legend also. That we'll do later. So now we can simulate the system. I'm changing the stop time as 6 seconds. So what is your input voltage? Input voltage is 30 volts. It's a constant input. My set point is 15. Let us see. If you look at the output, so black one is your input voltage, whereas blue one is the output voltage. It's maintaining set point value. Here this is nothing but your, this is input voltage and this one is output voltage. Fine. The black one is input voltage and blue one is the output voltage. Now the buck converter is worked in closed loop system. Suppose if you are giving a variable input, how to give the variable input? This system will work fine for the variable input also. I am directing this constant DC voltage source. So instead of that, I am going to give some variable input. How to do that is with the help of signal generator, signal builder. Okay, I'm going to use signal builder. So this signal builder is used for generating different signals with respect to time. Let us see how to generate the signal first. If you double click this signal generator, you may have so many options. Go to signal, go to new. So here if you want to create a constant, step, pulse, square, sawtooth, sampled sinusoidal, or if you want to generate some noises, Gaussian, pseudo random, something like that, you can generate. But I will generate my own signal, so I'm going to custom. So here you have to mention that x time values and y values, that is x values and y values. Here x is nothing but it's a time signal. First I will fix the values accordingly. Say that this 0, 1, 1, 2. So totally 10 inputs are there. Accordingly you have to give the same 10 inputs. Since it is a buck converter, I want to give some values which is higher than the one value. Say it is 1.5. And then last, you have to, the last two values will be, let it be 1.28, 1.28. So now you click apply. So this will be the input signal. Delete the previous one, old one. Okay, so now this will be the new signal, and I'm changing the axis as, let it be minimum time is 0, maximum time let it be 6. Okay, save the signal. Actually, I want to generate. So if you look at this amplitude of the signal, it's varying from 1.2 to almost 1 point, almost 2. But what is the set point actually here? It is 15. Okay, how to generate, how to make this equivalent is I'm going to multiply this amplitude value with a gain of this set point 15. Okay, then that will be your input voltage signal. Okay, so this values, this amplitude will be multiplied by the gain of that set point, this set point, that will be your input voltage. So what I'm doing is I'm using a gain. Value of that gain is 15, and then I need a controlled voltage source. So whenever a signal is given to the controlled voltage source, this will generate a equivalent voltage signal. Okay, so this controlled voltage source, the output of this gain is given to the S terminal of control voltage source. From there, you can take the positive and negative of your supply voltage. Now the system is over. I need one more gain terminal here for some manipulation. Okay, the purpose of gain is only for manipulation. I'm just flipping it. The gain value is nothing but it's 1 by 15. Whatever the set point you are using, that's the value 1 by 15. So now the buck converter is ready. Closed loop buck converter is ready for the variable input. I'll run this one. You can use the same KP value and K value, no issues. If you double click it, you can able to see this. So the black one is input variable and the blue one is output. Even the presence of varying input, the buck converter will give you the constant output voltage, which is always lesser than the input voltage. Yes. So now the system worked well. With a variable input, the buck converter will give you the constant output voltage. Hope this video will help you to develop the buck converter in closed loop manner with the help of PID. Thank you. Kindly subscribe the channel and videos. Thank you.